Hi, I'm Professor Pi. Come with me for another math adventure this day. In the past, we've solved two-step equations. And I told you the most important concepts within the algebra are you want a balance. You don't want the fat guy on the teeter-totter keeping you in the air. You want a perfect balance. If you subtract 7 from one side, you subtract 7 from the other. If you add 5 to one side, you add 5 to the other. If you divide by -2, you do it on both sides. Then we talked about the opposite order of operations. This morning, I put on some socks and some shoes. When I get home tonight, I'm going to take off some shoes and some socks. We talked about it's pretty hard to take off your socks without taking off your shoes. So we're going to undo backwards. We're going to undo addition, subtraction, then multiplication and division. That's how we solved two-step equations the other day. Y'all didn't seem to have a problem with it. Now, today, I've got equation with parentheses or variables on both sides. A1 SSE A1 is interpret the contextual meaning of individual terms and factors. Anybody know what any of that means? No. That stuff's up there for the State Department and the principal. Here it is in English. I can solve two-step and three-step equations using combining like terms and operations on both sides. I can recognize how to take the small value toward the larger value. And I have my video that I will post shortly here. CLT is combine like terms. In your book, it will be called simplify. Don't know what that means. Sometimes simplify means reduce. Sometimes it means combine like terms. Sometimes it means several other things in math, but combine like terms is the concept. If you've got a 2x over here and a 5x over here, you have 7x. Combine them. Now, my father at one time was a Marine drill instructor. If you couldn't polish your belt buckle just right, if your shoes didn't shine just right, if you were slow running the obstacle course, he had 2 piles of sand out back. Take the small one and put it in the big one. No, he didn't do that. He'd say, take the big one and put it over there. And the next day, he'd have some Marine that couldn't polish his belt buckle, take the big one over there. My dad did that to punish people. I don't want to punish you. Take a look at these 2 piles. If I told you to make them 1 pile, how many of you know that you should go the small one and put it in the big one? Makes sense. With the same concept, we have an example here. Example here. Take a look at this example. I'll work it in a second. Which side has the most x's? The 8 or the 6? The 8 has the most 6's. If the 8 stays and you bring the 6 over, that is, you subtract 6x from both sides, now you don't have much problem with negative numbers. If you take this big pile to the small pile, a lot of times you get a lot of negative numbers. So that's what I mean by big and small pile. If this were a negative number, is it smaller or bigger than 8? If it were -6, still smaller than 8? You would bring it up to this side. Keep the 8 there. If you had 8 and 18, you would take it toward the 18. That gets rid of some negative problems. Let's look at my first example. It's just parentheses. Now, what do you do with the parentheses? You distribute. 2 times x, 2 times 8, right? Is that what I did? 2 times x, 16. I got 2x plus 16, 22. Now, what do? You subtract 16 from both sides. You get 2x equals 6. And I didn't finish that problem, apparently, because I don't care what 2x is. What do I want to know? If I don't want to know 2x, what do I want to know? I need to know what 1x is, right? X equals 3. Now I'm done with it. Take a look at my next problem. We've already talked about, I want to take the 6 to the 8. I don't want to take the 8 to the 6. I don't want to take that huge pile of dirt and put it over here in the small pile. So what are we going to do? We're going to subtract 6x from both sides, right? Subtract 6x, not one side, because we want a balanced teeter-totter. After that, what do we get? We get 3 equal 2x minus 21, right? What does that look like? Does that look like what you did the other day? Two-step equation. You know how to solve that, right? We're going to add 21. We're going to divide by 2. So let me do that. Over here, I'm going to add 21. And over here equals 2x. Where did this 21 go? It left because I added 21. But I can show you what that looks like. It's minus 21 plus 21. And they canceled out to 0. Now, 2x is 24. What do I divide by? I divide by 2. X equal 24 divided by 2, which is about 12. I think I can count that on my fingers. I think it's about 12. Wait a minute. Okay. You can't count 12 on your fingers. And it will really drive me crazy if I see you going 6 times 72 and you're counting on fingers. Times tables need to be memorized. The division factors need to be memorized, because when you get to algebra, I'm not sure what finger X is. I'm not even sure what finger 12 is, but apparently I don't have 12 of them. All right, here's the last example I'm going to have on the tape here. We're going to distribute. Once we distribute, we still got X's on both sides. 5 times 4, 20. 20 times X minus 5 times 2. If you forget to distribute, that's probably the one you forget. That's minus 10 equals minus X plus 13. Now, I asked myself, is 20 or minus 1 bigger? 20 is bigger, so I'm going to move this one to the other side. I'm going to add X down here, add X down here, add X here, and what I get left is I get 21X minus 10 equals 13. Look familiar? That's the third problem I had you do last week when we talked about 2. When we talked about 2. Two-step equation, we're going to make it look like a one-step equation. Today we've got multi-step equations. We make them look like a 2, then we make them look like a 1. You do it one step at a time. What's the opposite of subtract 10? I think it's add 10. Plus 10. And I'm going to do it on both sides. Plus 10, which gets me 21X equal 23. So X is equal to 23 divided by 21. In this class, we're going to leave that. If it reduces, reduce it. But 21 divided into 23 comes out some 1 point something. I don't care about the something. We don't need a decimal. Now, if you're on a calculator, you can give me the decimal. Thank you for visiting with Professor Pi. Please come back another day.